Um, I'd like to welcome everybody to this session on Docker. My name is Donnie Hamlett. Just to give you a quick intro into who I am, my background is I'm an electrical engineer, so a long time ago, and I won't tell you how long because that will reveal my age. I got a degree in electrical engineering, graduated from Prairie View A&M University in Texas. I've been in IT for over 16 years. And primarily I've worked as a system engineer, but I've had a bunch of interesting um, uh, career experiences. So some of the companies I worked for in the past include Microsoft, Cisco, a startup that I was one of the founders of, which is called CloudStream, and then a company that does data center discovery out of Dublin, Ireland called iQuate. And today, I kind of do a lot of things. I run my own company called Recruit for Cloud that focuses on placing DevOps engineers and cloud developers, as well as doing installations and deployments of private cloud. And I also work for ServiceNow as a curriculum developer. So I wear a couple of different hats. I met Women in Linux because I happen to be president of the OpenStack Central Florida user group. We're one of the largest OpenStack user groups in the country, and one of the really cool things that we have is a project called the Community Cloud. So we were sponsored by our sponsor HostTime. We have some equipment that's in their data center. HostTime's a hoster who's based out of Orlando, who have hosting offices all over the world. And to make a long story short, we make an OpenStack cloud available for people to get hands-on experience learning, as well as to use and consume. So I'm sure that Women in Linux, we're going to talk more about that at a later date. And I'm also on the board of directors for Women in Linux. So that's a brief introduction about me and kind of how I know the group and what I do. So let's talk about the session objective for today. The goal of today's session is by the end of the session, you should be able to explain what a container is. The goal is to help you understand why Docker is a game changer, and it really is a game changer. If you've had any exposure to technology in the last 2 years, you can't escape Docker, and we'll talk about why it's a significant game changer. We're also going to talk about how we find documentation for Docker and how we install it. We're going to do a basic walkthrough of the Docker commands. We only have 45 minutes, so we're really not going to be able to get into the nuts and bolts of everything that Docker can do, but the goal is to give you enough understanding of the commands that it will allow you to set up and run a WordPress within a Docker container. And by the end of this, you should be able to run WordPress within a Docker container. In fact, I provided my contact information. So if you decide to take on this project of running WordPress with a Docker container, you can reach out to me and ask me for help, and I can point you in the direction of how to do it. So let me just check with everybody. How's my speed? So just give me some feedback. Am I talking too fast, too slow? Give me some feedback
You
at this
got good
point.
speed, Donnie.
Okay, good. All right, cool. So let's rock and roll. I'm a New Yorker, so if I start talking real fast, don't get mad at me. All right. So let's talk about the history of Docker and containers. So first of all, the container technology is not something new. The way it's marketed, the big buzz about it and the move by so many companies to embrace it, it's really an old technology. It existed in the Unix world for many years, and we can see it in systems like FreeBSD, which is what they had the jail utility, Solaris Zones around 2001. The first company to bring it to the world of Linux was a company called Parallels with Virtuoso Linux, which they released in 2001. And what kind of sparked everything is that Parallels open sourced it as OpenVZ in 2005. So that was the move when container technology kind of moved to the world of Linux. Then around 2007, really before that, Google had adopted it because Google was trying to figure out the most efficient way to run their infrastructure. So they were one of the main vendors to really embrace container technology. And they did a lot of work around C groups for for Linux, to help bring the technology to the Linux world. And what this did is that by 2008, they released a project called the Linux Container Project, also known as LXC, which is kind of like a standards board for Linux containers. And it includes many of the largest technology vendors. In fact, if you can name a technology vendor, you'll probably see them participating in that project. Now, the core of the technology is based on something called namespaces and Unix C groups. So if you really want to dig into this some more and get a better understanding of it, that's where I would direct you to go. Now, the interesting thing is that prior to it being embraced, and even though it was embraced in 2008 on Linux, it wasn't widely used. And the reason why it wasn't widely used on either the Linux or Unix platforms was because the technology was simply very, very difficult to configure and use. So the issue wasn't the technology, it was a function of usability with the technology. So let's move forward to 2013. When we move forward to 2013, the founder of Docker, Solomon Hykes, released the Docker project. He'd worked for another company doing cloud computing, and he realized that the potential that containers had. So they released this new version of containers written in Golang with a really friendly user interface. And what makes it special is that it has an engine that makes it easy to create and run containers. That Docker engine runs on all platforms. So it runs on Windows, Linux, Unix, and Mac, which is pretty incredible when you think about it. And then the other piece that they added to, not only just making it easier to run, is they added what's called a hub. And the hub is just a repository of images. And these images are approved and signed by the different software companies that will produce it. So, for example, you can get an approved image from Ubuntu, or you can get an approved image, a CentOS image, or you can even get an approved WordPress image. So what vendors have done is that they've taken their image that they've produced and they've released it to this repository, in addition to other people as well. So if you want to build an image, and hopefully we'll have a chance to see it if it doesn't take too long for us to run, it will actually, if you call an image name and you don't have that image locally on your machine, it will actually reach out to the repository, check for the image name, and if the image exists, it will download it to your computer so you can begin using it. And that's pretty powerful when you think about it. Now, just for a little bit of, if you were going for a job interview and someone was going to ask you the stump the chump question, one of the things to know about Docker is that the name Docker is a type of waterfront workman. And all the names associated with Docker, many of them are typically related to water. I won't say typically, a lot of them are related to water, not all of them. But that's just good to know. And when you think of and let's just move on. So we'll go on. So let's talk about the big deal. So what's the big deal around this container technology? What's all the buzz? What's all the fuss about it? Well, let's explain it in terms of resources and cost. So let's say that I have this server that's sitting here in front of me, and that server costs $10,000. If we want to be cheaper, we can bring down the cost of that server to $5,000. That's a decent cost of a mid-range server. In the past, and when I'm talking way in the past, we would be able to install one operating system onto that server. So think about this. You paid $5,000. You can install one operating system, and an operating system, if you're running in a server environment, will typically run one application unless it's a web server. So you're not getting a lot of bang for the buck for $5,000. And what's happened is that as servers got faster, as the underlying hardware got faster, there was less utilization taking place on that hardware. So you could spend $5,000 for that server, and you may be utilizing like 10% of it. So you really should have paid for a $500 server instead of a $5,000 server. So they had to do something about that. So in the mid-2000s, the technology that bloomed and got really big was called virtualization technology. And this technology was championed by VMware. That would be the poster child for it. And they did something pretty phenomenal. Instead of being able to just run OS on a hardware that you paid $5,000 for, well, with the magic of virtualization, machine virtualization, so you basically have software that tricks the underlying hardware into believing that, I should say it tricks the operating system into believing that it's running on the underlying hardware. But in essence, that operating system is running on a virtualization software. And what that did is that enabled them to get lots of versions, different operating systems onto one host, a virtual host, or what would be called a virtual server. So we can look here, we have an 8-to-1 ratio, where instead we had one before, we now can load 8 or 10 or 12, or some of the larger systems can hold 50 VMs on a single server. Now think about that. Imagine if you have now 50 VMs and you paid $5,000 for it. I think, what is that, like $100 or is it $10? I'm not sure what my math is looking like. I think it's 10. But it's $100. The cost has gone down drastically for you to run that infrastructure. So let's move to today. Today is 2016, but let's go back to 2013 when containers appeared. And they noticed that it was very phenomenal about containers. Containers gave them the capability to run more workloads, and it's not really operating systems, but more workloads that acted and functioned like operating systems, and we're going to call them containers, on the same hardware. So I want you to think about this. VMware went to a billion-dollar company in I think about 5-6 years. So it wasn't very long before it went from being a startup to a billion-dollar company because the technology was so well embraced. Well, we're seeing something similar with containers because of the density that you're able to get from the existing hardware. And because you can run all these containers on that same physical hardware, there are a lot of people who are interested in this technology. So it's just getting momentum. You're kind of at the start of a revolution. It's not as mature as virtualization. It has some limitations. It's lacking in some capability, but the technology is so good that many companies have already started using it in their production environments, even though it's still a work in progress, right? And that's what this is about. If you're going into the world of infrastructure, and Linux, it doesn't make a difference now. If Linux or Windows Server, I know I'm not supposed to say that, but I used to work for Microsoft, or Windows Server, or Unix is your platform, then you will have to, in the near future, understand containers. So this is going to give you a jump start on that. Any questions before you can just turn your mics up and ask me a question if you'd like to. Okay, good. We'll keep rolling that. So let's talk about this. Let's talk about why is it that we're able to get why is it that we're able to get greater density of containers on physical hardware than with virtualization. So if you look at these two pictures, and what I'm going to do is I'm just going to highlight it. You'll see you have your underlying infrastructure. You have your operating system. On the left, you have your hypervisor, which is going to allow you to, it's going to be that software that will trick the operating system to believe it's running on its own piece of hardware when it's not sharing. And then for virtualization, you're going to have a guest OS. You're going to have whatever libraries you need or required for that application to run, and then you're going to have the application. And then this is going to repeat. Now, if we compare that to the Docker container, we'll notice that it's a little bit different. We have the same infrastructure. We're going to have a host operating system, but loaded on top is going to be the Docker engine. And then if you notice, the apps and the bins go directly on top of that Docker engine. Who can tell me what's the difference between these two pictures? You thought this was going to be interactive, right? You thought I was just going to talk the whole time. So who's going to tell me? Come on, we only have 45 minutes and you got to talk to me. Who's the brave soul out there? No one? Don't let me call somebody.
Pam said the VM engine.
Okay, that's close, Pam. You're very close. Go one up, go one higher. I'm waiting. Pam's close, but that's not quite it. Someone else throw it out there. I'm looking. Y'all must have just ate lunch, and now y'all all sleeping in my class. That's what happened. Thank
Linda
you,
said
Linda.
the hypervisor.
You're close. You're close. Go higher. Go north. Go north. What's it? You said the hypervisor. You said the VM engine. What's the guest OS? Excellent, Linda. Thank you so much for participating. I wish I could give you something. The answer is the guest OS. So that guest OS is massive, right? It from a compute perspective, when you install an operating system, it's taking hundreds of megabytes. It has updates to it. It is consuming a lot of the compute resources. So that guest OS consumes a lot of the resources, and it's a kind of a fat if you want to think about it. When we talk about containers, what we're essentially doing with containers is that we're trimming the fat away, because the only instance of our operating system is the one that's tied to the underlying hardware. And the Docker engine runs on top of that. Now, there's going to be a limitation we're going to talk about later on, and I'll share it with you right now. One of the downsides, and I'll talk about it more a little bit later, is to container technology is because the operating system is shared for all of the containers. All the containers must work with the same kernel. So what does that mean? On a hypervisor system or a virtual machine, each one of those apps could run on a different operating system. So the one could be Linux, CentOS. The orange one could be Ubuntu, and the reddish color one, or the dark orange one, could be Windows. When we look over and compare it to the Docker, all three of these apps would have to be some flavor of Linux that uses the same underlying kernel. So it could be CentOS, Ubuntu, and it could be RHEL, Red Hat Enterprise Linux. They would all be able to run, but we wouldn't be able to put Windows on that system, or we wouldn't be able to put Solaris on that system. So that's one of the limitations. But again, the cost performance is so great that companies are really embracing this technology. But wait, there's more. You ever see those commercials? I don't know if they had those. We had this guy in New York called Crazy Eddie, and he'd ramble on all excitedly, and then he'd go, "But wait, there's more." Or the Norelco commercials, but there is more. So some of the cool things about Docker and container technology is that it's smaller than VMs. So these containers can typically be maybe 10 megabytes, 100 megabytes, 200 megabytes. You can get bloated ones that go into gigs, but they're relatively small. Because they're so small, they're easy to move around. And that's why they have the name container, because containers are easy to ship from one place to another. Once you pack the information in that container, all you do is stick it on a boat or a train or a truck, and it gets to wherever its destination is going to be exactly the same. So they're smaller. That ability to move them, to transport them from place to place, makes them better for development. So we could build a Docker container with our application in it, and we can move it from our desktop to a hosting platform that would run it. Let's say Google, for example, or AWS or OpenStack. So very, very powerful when it comes to development. Also, it's much faster than VMs. Now, this is important. When you begin to talk about web scale for these companies that are spinning up hundreds of servers or thousands of servers to meet spikes in demand because they have this cloud infrastructure to support them, then one of the issues becomes how fast does that machine turn on and how quickly you're able to configure the machine. If you've played with VMs in any type of cloud like a Google Cloud or Amazon Cloud or OpenStack Cloud or Azure Cloud, and I can go on, you know that there takes some time before the VM starts up. And the VMs can take as much as a few minutes before they start up and get up and running. If you compare and contrast that to a container, containers can get up and running in milliseconds. So when you're trying to build environments that are able to scale up and scale down rapidly on demand, and you have applications that are very responsive and time sensitive, then containers are phenomenal. Now, another feature of containers that we won't really be able to address in this session, because it's just, it's too big of a topic for just 45 minutes, is that containers make better use of storage. So you can dedicate, for example, a container to run storage. You dedicate another container to run a database. You dedicate another container to run the web browser or web serving engine. And that's how you build containers. You make them very single function and you link them together. But one of the cool things they can do is they can use a container for storage and have multiple containers point to that single container that contains all the storage. And the other cool thing about it is that you can take that container with the storage, and because it's a container, you can move it from one storage platform to another storage platform to another storage platform without affecting the application. And that is pretty powerful. Also because there's no operating system to go through. We're not in a virtualized environment. We're going through n number of operating systems, and we'd have to look at their monitoring and metering to pull back information from them. In a containerized environment, there's only one guest operating system. So it makes it very easy to collect everything from the containers. And all the information from the containers, which you'll see later on, are written into text files. So it's very easy to reach into a container, figure out what's going on, and to optimize that container on the fly through different management or monitoring tools. The other phenomenal things about containers is they have the capability to be cloned very easily. So it's easy to make copies of containers, and you'll get a chance to look at that today. But the ability for them to make replicas or copies themselves is incredibly powerful for scale-up environments. It makes containers highly unscalable. When you use containers with technologies like Swarm, which is a Docker technology, Mesos, which is a technology that's used for orchestration of containers, and Kubernetes, again, another technology. Kubernetes is by Google. It's a technology that Google used for orchestration of containers. They can get environments that you can't really kill. The environments are so intelligent that it monitors what's happening with these containers, and it's able to spin up and shut down containers as needed by the environment. So the containers really kind of meet the requirements of web scale environments. And that's why Google was one of the first companies to really embrace the use of containers. If you get a chance to, go on YouTube and look at some of the videos for Swarm, for Mesos, and Kubernetes. It's mind-blowing. I had an opportunity at the OpenStack conference back in, I believe it was May, or it was June. I think it's May or June of this year. Can't remember which. They basically were running an OpenStack cloud, some of the services on the OpenStack cloud, in a Kubernetes, in containers within inside Kubernetes. And what was fantastic is that it made the cloud resilient. So it was a combination of cloud and containers that produced this phenomenal level of resiliency. Any questions? Okay, so let's keep going then, if there are no questions. So there is a downside, right? Some of the downsides to containers, which I talked about earlier, is there's only one OS. So it's a all or nothing type of approach when you get to container technology. So it either has to be all Linux or all Windows or all Solaris that's running there. Two, there are still some challenges around security and isolating the containers. So because the containers share the same underlying operating system, you can have issues where containers begin to consume more resources they're supposed to and starve the other people who are on the host. There's a lot of companies who've done work around that. I'm not sure to what degree it's been fixed, but that has been one of the challenges that's tied to containers. And another challenge that's tied to containers is that they're not quite yet optimized for all types of applications, and they're working to address these things. Again, the capabilities and powers that containers gives to these companies is making them come up to solutions for all these issues. So let's talk about getting started. And I need to be able to see my screen. If you are new to Linux, if you haven't used Linux before and you're not familiar with working within a command line, then what I would suggest is that you use Ubuntu. You can get any version of Ubuntu you want, 14 or higher. Go with the LTS's releases of Ubuntu and use the Unity desktop. What the Unity desktop will do is it will allow you to spin up a terminal, but it will allow you to cut and paste between a web browser and the terminal, so you can configure that Ubuntu server with Docker. So it makes it very, very easy. So that's the environment I'd recommend to you if you were getting started. And it's an environment that I'm running on my desktop. The other thing that I'd like you to do if you're going to get started with Docker is you need to sign up for a GitHub account. A GitHub, all the information when we're talking about Docker can be stored in text files. And because it can be stored as text files, you can make configurations and builds for Docker, and you can store that in your GitHub. So whenever you want to actually build a new image, all you can do is you can point the Docker engine at your code, and it will build out that new instance. So you definitely want to look at getting a GitHub account to act as a repository for your code. The other thing you want to do is you want to sign up for a Docker Hub account. The hub is going to give you access to the other images that exist out there. You can readily download images, but you get to upload your own images into the repository that you may want to share with teammates, or you just want to have when you're building a machine and you need to pull an image down. And then the other big thing I would tell you is to get started with Docker, you're going to need to follow the directions on the Docker website for installation. Installation is a little hairy with Docker, but you just have to be patient and take your time. So what I've done is I'm going to try and walk you through what the installation process looks like. And I'm going to be careful for time because there's some other things that I want to show you. So I'm just going to get you started to show you where these installation guides would be and to walk you through how you cut and paste to be able to install and configure Docker. Any questions? Okay, so give me a second. I have to figure out how to escape. There we go. Uh, Give me a second to get to my window. Okay, there we go. So that's my terminal. And you have to forgive me, I'm not quite as graceful on a Mac as I am on my Linux machine or my Windows machine, so it's a little bumpy. So the first thing we're going to do is that we're on this terminal. And what I'm going to do is I'm going to go and I'm going to Google Docker installation. So let me go to Chrome. I'll go to Google. And what we'll type in is install Docker. And in fact, I'll do an install of Docker on, I don't have to type Ubuntu, so we'll just go to install Docker. There we go, so install Docker, and we'll click on Ubuntu. And we can see that this is going to walk us through a guide of how to install Docker on Ubuntu. Now, what I suggested is that you work in an environment that will make it very easy for you to cut and paste with. So for me to kind of begin to go through with this, I would simply right-click the command. I'd select copy. And you can do this again if you're working on a Ubuntu system that's running the X Windows, the Unity interface for it. I'll go here and I'll paste it. So uname R is going to give me information about the version of Ubuntu that I'm running on it. Right? So let's see if that's good so far. Let's go back to our Chrome page. Okay, I'm doing good. I'm at 3.11, so that's not too bad. So the next thing I need to do is I need to do a sudo apt get update. So I'm going to update the system. I'm not going to go through that because I've already done an update against the system. You typically want to do an update before you start anything. The next thing we have is a sudo apt get install, and these are going to be certificates that it's needed to run. So I'll copy this. Oops, on the wrong system. There's my apt get install. These are certificates. And I have a permission denied. Let's type in a sudo. And let's see if that corrects it. Good, just want to make sure my spacing is okay. Still may kick me out, but that's good. and it pulled down the files. I don't like to work on Ubuntu. One of the reasons for is that I just hate working through the sudo command. So, and that's why. So sometimes you'll think you'll type something in wrong, and the reality is you didn't. You just forgot to put in sudo. So let's go back to our going through. Let's see. This is going to force us to pull down the latest version of Docker. So we could probably do an apt-get and pull down Docker directly, but what this is referring to us to do is to get the latest version of Docker. So what it wants us to do is it wants us to put this in its repository so we can get the most up-to-date version of Docker. And we could do that as well. I'm not going to do that at this particular point. I'm just going to move forward with it. It's going to walk through. I could do an excuse me, I could do a apt get update. We did that again. I don't want to purge to see if there's new ones. At this point, I just want to do an apt get and get Docker. All right. So that's what I want to do at this particular point. So I'm skipping through. And if this doesn't behave correctly, I'm kind of skipping through steps for the purpose of time. I have one that's already built, so we can still get through our demo. But this is just to kind of walk you through the process again that you would use to build out your Docker. So I'll do paste that. So it couldn't locate it, right? It was unable to resolve it, and that's because we didn't put that pointer in. So I have to go back to the files. I have to create that apt-get list, and I have to stick that in. Let's take a pause right now. Do you guys want to see me do that, or would you like me to get into actually using Docker? I'm pretty sure everyone watching this can follow through the steps necessary to install and configure Docker. So just let me get some feedback. What would you like to see me do?
I'd like to see you use Docker.
Okay, good. I was hoping you would say that. All right, so let's jump into Docker. So let's make believe that we magically installed Docker, and now we want to get into actually using Docker. So let me get back into my presentation. So before we get into the to actually using Docker, there's a concept that I want you to understand, and there's a concept of an image. And when we're working with a image, is what we're going to download. It's the actual details of that's the actual thing that will come from the Docker repository, and from the image, we're going to build containers. So I have a little animation here. So we're going to do a Docker run command. The Docker run command is going to build a Docker container. And then at that particular point, that Docker container will be disconnected from that image, right? And it's simply an instance of the image. And I can spin up as many Docker containers as I'd like to spin up. Right, so let me get back to my container. And what we'll begin to do is we'll do this as well. We'll talk about the Docker command. So when we're looking at the anatomy of a Docker command, all the commands for Docker are going to begin with the term Docker. So for example, the simplest command that you'll have, and let me just undo that, didn't need to modify that, will be Docker version. Then the next thing that we'll look at as it relates to this will be more advanced commands. So we'll always see it preceded by Docker, and I'll just bump into this. We'll always see it preceded by Docker. Then we'll get a command that will go through it. So this will be the run command. The next piece we're going to see, which says busybox. Busybox is going to be the name of the image that we're calling. And then we're actually going to ask the container to do some work. So we typically will pass a command to the container. Now, there are a bunch of commands that are available on Docker. If you're ever trying to figure out how to configure and set up a command, the best way to do it is just to press Docker. It's just to type in Docker and help. And you can get a listing of the command. So let's go into my pre-built machine over here. And let's begin to run some commands against it. So the first thing we want to look at is we want to look at what version of Docker we have. So you install Docker, and the first thing you want to do is you want to check the version. You know what the latest version that you're running is, right? So pretty easy. Now let's do the Docker run command that we talked about. The Docker run command is going to take an image, and it's going to spin up a container from the image. So what we're going to do is we're going to call a container, we're going to call an image that's called BusyBox. And BusyBox is a scaled down version of Linux. It's very tiny, very small, great for demoing. And what we're going to do is we're going to pass, we're going to have it launch bin, and to the bin command we're going to pass echo. And for the echo, instead of saying hello, we're going to say what's up, right? So what this should do is it will look for BusyBox. If it doesn't have BusyBox on the machine, it will reach out to the repository of Docker Hub and pull it down, tell us it's pulling it down, and then it will run the command. So let's run this command. And there it happened. Now, that doesn't look very exciting, does it? Right? It looks like nothing kind of really happened. Like I could have typed echo and what's up, and I would have got the same thing. But really something kind of magical happened on the back end. So there's another command I'd like to show you, which is called Docker, and it's called images, right? And images is going to give you a list of the images that are on the machine. So when I talk Docker and images, you can see not only do I have a BusyBox image, which is located at the bottom of the screen, everyone sees that, I also have a series of other images that I have worked with as well. Right? I have a Hello World image I created, a Debian image, and a CentOS. So it means that we're going to have the capability to build anything, I should say, containers based upon the images that we've downloaded. Now, if you want to download any of these images, again, you just type Docker, you run the name of the image, and it will download the image from the repository to your server or your desktop or workstation. Now, we still haven't gotten any information about the image that we just ran, that instance of BusyBox. So what we have to do is we have to do a PS command. So similar to the Unix PS command, we need to type a PS, and then we need to have an argument of A. And a PS and argument of A is going to show us all the past containers that were run. So what happened when we called Docker run BusyBox and we passed it we called it the bin and echo and we passed it what's up, is that it opened up a container, it did the work that we asked the container to do, which was bin echo what's up, and then it exited. So that's what containers do. They will pop up, they will exit, unless we give it other directions not to do that. So let's pause for a second and let's look a little bit more at this. Let's do a Docker. And there's another command that's called inspect. And what inspect will allow us to do, it will allow us to get some information about that Docker container that just ran and closed. So we'll do Docker inspect, and we have to give the name of the container. Now, if you look here, the container has something which is called a container ID. Hope you guys are seeing that, right? And this container ID, we can call a container that's run by its container ID, or these containers always have these weird names. It's usually tied to a scientist, but you can also call it by this name. I guess it would be called a friendly name. So those are the two ways that we can refer to that container. Typically, when we're running Docker images, we're running Docker containers, we'll get a lot of these. So we can get 10, 20, 30, 40 of these popping up. So we need these names to identify the container that we're working with. I'm going to run this, and then I'm going to ask if there are any questions. So let me just run this command, and I'll walk through the output. And then we'll open up some questions. So I told you everything in Docker was contained pretty much in a text file. And when we do Docker inspect of that particular container, not the image, but the container that we ran, we get some information about it, right? So Docker inspect, we get the ID of it. You can see that this long ID here is the same as the ID here that is for the container ID, but this is a shortened version of it where this is the complete uh, um, container ID length. We also have a created period here. We have the path that was used, and we have the argument that we passed to it. And then these things are important. I want you just to take a moment to look on these states. These states are what is happening with the Docker container. In our case, the container that we were working with, it exited, right? So the status was it exited. We can run a container, and we will run a container in a few seconds. It will run, and it won't have that state. It will be a running container. So this gives us insight into commands that we're going to run later on. We get image information. We get log file information for it. So we can also run a Docker logs to look at the log file information. So everything that happens in the container is written to a log. You can see mount points, drivers, a bunch of stuff, network settings. We can grep against this. So anything that you see in this file, hairpin mode, IP link local IP address, we're able to IP address, right? Any of these attributes that's associated with this JSON file here, we can go in and we can grep against it and pull it out. So it's a great way to get information about our Docker images, I should say containers that have run. So let me pause for a second.
Thanks,
And let me
Donnie.
ask if there are any questions.
How much? I know you are like knee deep in it, but we are definitely need to wrap up for our next session. This
Okay.
is not the first or the last time you guys will hear from Donnie. He will definitely be back for the remaining Docker presentation, and then his slides will be available afterwards. You guys can you make yourself available for a Q&A when we wrap up here, Donnie, in your
Yeah,
booth?
yeah. And I'm almost done too. Can I get just like 5 more minutes?
Nope.
Because I didn't have a full 45 minutes. I only had 38 minutes. I was timing myself.
Yeah, tell you.
It's all good. So if you'd like to sync up with me, the presentation will be made available. I've written out all the commands that you can run against your Docker container. The only thing really left for you to do is to run a container in what's called interactive mode. And the command to run it in interactive mode is just a Docker run with a -it. When you run in interactive mode, it will give you a shell that pops up, and you can do anything in the shell that you could do on a regular Linux server, and you just type exit when you're done. And the last piece about it, if you want to run that like a web server, you want to install something in it and run it like a web server, you would run a -d with the run command, which means detach. And then you'd have to map the ports out to a port that the person could access. And this is simply making a web server container available to the public. And then the last is that once you're done with whatever you're going to do in that Docker container, you do what's called a Docker commit. Very easy. You're going to give your author name. You're going to give some metadata, which is the -m for it, and then the name of your Docker file. And that's it. That is the whole. You can run all these things on your own. They're pretty easy to run. And if you have questions or you want more details on how to configure it and set it up, you can reach out to me. I'm tasking everyone who's listening to this with setting up a WordPress server using Docker. So thank you very much. If you have any questions and you want to reach out to me, I'll be in my booth, and my email is also here. I'm dh@recruitforcloud.com, and you can tweet me at DonnieHam1.
Thank
Thank you.
thank you, Donnie.
Cool.